Two common vocabulary words for talking about angles are angles of depression and angles of inclination. Oftentimes when making a real world measurement, angle measurement, we usually measure from an imaginary horizontal line. And I shouldn't even say that it's always imaginary. Quite often it's the ground, but you have to assume that the ground is level and horizontal. So to start with, an angle of depression is measured below a horizontal line. So this would happen when you're up high and looking down, and an example would be this airplane. If it wanted to measure an angle down to some landmark like a tree, it would measure from the horizontal down to the appropriate angle. An angle of inclination is the opposite. So we sometimes call an angle of inclination an angle of elevation. Both mean the same thing. And this is an angle that's measured above a horizontal line. So you'd be down low and then making a measurement up towards some landmark. So if you were down here at the tree and you were looking up at an airplane, you would measure an angle of elevation or an angle of inclination up to where the airplane is. Now, one thing we have to consider is that there is a 90-degree angle between horizontal and vertical lines. So in this picture, we have this person on the roof looking down at a soccer ball down at the ground, and they would measure an angle of declination from some imaginary horizontal line down to looking at the soccer ball. But if you were imagining using this information to calculate the distance to the soccer ball, maybe we could call it x, you might instead choose to use this other angle in this big right triangle here, because here we have a right triangle between the ground and the building that the person is standing on, which means that we could use the fact that this angle plus 17 degrees is equal to 90. So this angle in this triangle would be 90 degrees minus 17 degrees, or 73 degrees. So that's just one way to sort of start from an angle of declination and then turn it into an angle that maybe makes more sense physically so that you can make a calculation like a length or a distance. Here's an example. Brian needs a wedge to support a beam against a wall, and the beam is supposed to have an angle of elevation of 70 degrees and reach 5 feet up the wall. So in order to solve something like this, we need to know the length of the beam. It always helps to draw a picture. So if we have a beam supporting a wall, I'm going to draw the ground and the wall. And then we're going to draw the beam that's wedging the wall. So it's supporting the wall. And it supports it at an angle of elevation of 70 degrees. So that's from the bottom going up. We're told that this is 70 degrees. And lastly, we're told that the beam reaches 5 feet up the wall. And we want to know the length of the beam. So we could call that x. So we're looking for the hypotenuse of this right triangle, which is this beam braced up against a wall. Now we're ready to set up an equation. So we know the opposite side from 70 degrees is this 5-foot distance, and the hypotenuse of the triangle is x. So we have the opposite and the hypotenuse. From SOHCAHTOA, we'd be choosing sine. So sine of 70 degrees is opposite divided by hypotenuse, or 5 divided by x. And now we're solving this as though, or we're solving it with the unknown in the denominator, which means getting rid of it from the denominator by multiplying by x on each side. And then we're going to divide by sine of 70 on each side. And so you can see I'm kind of doing this in one big step. You could do it in 2 smaller steps if you want. But that leaves us with x is equal to 5 divided by sine 70. And when I do that, I see that the beam needs to be equal to 5.3 feet long.